Hi everyone, happy International Women's Day. I'm Dora and I'm going to be your guide today as we explore a fresh and practical perspective on authentication architecture for the modern open web in my talk titled Zen and the Art of Edge Authentication. And without further ado, I would like to launch into an inquiry on Zen, the adjective, not Buddhist tenets, meaning being relaxed and not worrying about things that you cannot change. And I would like to maintain a sense of Zen while we explore together the world of edge computing, a world that is very squishy and still rather being born. And that just means bringing computation and data closer to the location where it is needed. And authentication, which is the process of verifying the identity of a person or device. It is something we do every day. We use login forms, we use various codes on our devices and so on. We're going to talk about edge computing in the context of large-scale coordination-free distributed systems. And we're going to talk about building secure web authentication. What I mean by that is secure login flow specifically. So I have two humble goals for our time together today. I'd like us to all get a bit better at secure web authentication, and let's also try to have an interesting 30 minutes. I don't know if you picked up on the literary reference in the title of my talk. It is one of my favorite books, written by Robert M. Pirsig in 1974, called Zen and the Art of Motorcycle Maintenance. And I like books and I like motorcycles, and I can't resist a good reference in my talks, but I also like the philosophy of that book. And if I were to paraphrase Robert Pirsig, if he were building login forms, I would say other people can talk about how to expand the destiny of mankind. I just want to talk about how to fix authentication. To understand how to fix it, I suppose I better start with telling you what I think the perfect web app authentication should be. It should be distributed, it should be close to the end user. It should be isolated from the rest of your system and secure, implemented by security professionals who also maintain it ideally. It would be fast and also minimally annoying to integrate and maintain, and it would expose as small as possible a surface area for integration with your system so you can focus on building really cool stuff. So that's the perfect web app authentication. However, as most developers can attest, if you've ever had to deal with security protocols and identity tokens and user and device authentication, that all can be very challenging. I speak from experience when I say that authentication is scary and difficult, dangerous sometimes. It's very expensive to get wrong. And it's also essential. Most apps need it. It's an early precondition on pretty much every user request. And we tend to get it wrong a lot. So it turns out that the Open Web Application Security Project, OWASP, have been maintaining the authoritative list of the biggest things we get wrong on the web in terms of security. This is a top 10. It's been going since 2003. And for the past 18 years or so, broken authentication has been very near the top of this top 10 list of very critical risks that we should all do better to mitigate. Why do you think we get authentication wrong? Well, according to OAuth, we don't implement it correctly, and then attackers can compromise passwords, keys, or security tokens, and exploit various other implementation flaws and assume our users' identities, either temporarily or permanently. And there are just so many cases. Not a week goes by without a major leak being exposed and so on. And often, we get the blame. But people tend to forget that developers are, who's the attacker? Attackers are also developers. And frankly, I think the problem is that we don't have any perfect internet-wide authentication protocols. So we have been doing this since the Stone Age of the internet. We've had login forms, we've had databases with usernames and passwords. We've done all of that pretty much since we've been doing web pages. But here's the problem. If you want to understand how to secure something, how to secure protected content, you kind of start by looking at how does everybody else do it, or how do the experts do it. And the experts are people who tend to get together and agree to be wrong together and be accountable for being wrong together. But they're also the people we trust most. And the experts gave us Federation and Delegation and SAML and SSO and MFA and OAuth and WebAuth and FIDO and OpenID Connect, UMA, IndieAuth, and a bunch of security tokens. Off the top of my head, JWT, Hawk, Pasito, opaque ones. There's just far too much to keep track of. So in the face of all this, I just want us to maintain the zen, the adjective, the not worrying too much, because it is very hard to build the perfect web authentication in a world where there are so many standards and don't have an agreement, and there's often conflicting information out there. It is still possible to get it right, and I will show you exactly how to do that. Okay, back up a little. So we want to build something that's fast, distributed, secure, autonomous, neat, not annoying to integrate and maintain, something that works for a distributed system and something that covers like really wide bases of use cases. What ingredients do we need? First of all, we need whatever the awesome thing is that you built that you want to protect access to. Then we're going to pick just a few of these mature standards. I'm not going to read about everything. We are going to trust the industry standards on this one. We're going to need an identity provider. And what is an identity provider? So identity providers are services that create and maintain identity information and then provide authentication services to your application. So if you think of Twitter, GitHub, Google, Auth0, Okta, and quite a few more, those are all identity providers, and those save you the trouble of having to build your own authorization server. They've gone and read the standards and implemented something that is really secure and trusted, and you can get started pretty much for free. So we're just going to use one of those. And here's what magic ingredient I'm going to add: something called an edge authentication service. And we're going to use a super cool new technology that I can't wait to tell you about. So let's see if we've covered our bases. Mature standards should mean that what we're building is secure. Identity providers are secure because they have to be competitive. Edge authentication service is secure, and I'll explain why. Identity providers need edge authentication by virtue of being autonomous from the rest of your system is also neat and should be fairly easy to implement and just ship. And also, what I'm about to propose is not only secure and neat, but distributed, autonomous, and fast. And here's how it's all going to work. So imagine an end user in London. They're going to make a request to visit a protected page on your origin server. Say you have a very popular cat blog, but you don't want your personal cat photos to be available to just anybody, and you'd, like perhaps subscribers to be able to access them. Instead of hitting your origin server directly, they're going to hit our edge authentication service, which will be a Fastly node in London. That would be our edge node. I'm going to explain a bit more as time goes on. Now, It is then up to the Edge authentication service to verify the authentication status with the identity provider. If you're not logged in, if Fastly at the Edge determines that the end user in London isn't logged in, then the identity provider, so imagine you want to sign on with Google, you have the Google login form, it is between you and Google to handle the logging in. And then eventually, you deal with all the logging in and you get back in this loop. The Edge has verified your authentication status and it can pass the original request to the origin, and we can send back some really lovely cat photos. Cool. Without further ado, I'm going to jump straight in. The mature standards I'd like to talk about today are OAuth and OpenID Connect, OIDC. Now, OAuth has been around for many, many years. It started at Twitter. And it's perhaps, the most widespread protocol for authentication on the internet today. So I used it when I submitted this talk for presentation using this app called Sessionize. It was really cool. So I could log in with Twitter, with Facebook, with Google, Microsoft, Office 365, and at the very end, there's a button with classic login, because nobody really wants to deal with the trouble of maintaining a secure database these days. Cool. You'll have noticed that I mentioned both OAuth and OpenID Connect. Why are they not a single thing? To understand that, I have to make a pretty important distinction between something called authentication and authorization. And a lot of the time people use these interchangeably, and a lot of the time it frankly doesn't matter, and you will you should only worry about the sort of the minimal surface area of interaction of your systems with either of these two functions. So I'm going to use a metaphor here. Take, for example, international travel, something that we probably haven't done very much lately. If we were to consider authorization in the context of international travel, this would mean that, okay, you have a passport. It's neither fake nor expired. You have appropriate clearance for what you're trying to do, for example, a valid visa to enter a country. Great, you have permission to enter our borders. Authentication, on the other hand, is I'm looking at your passport, I can tell it's your passport, your photo and biometrics match, and I have verified your identity. So authentication is all about knowing who you are. Authorization is knowing what you're allowed to do. And the only thing that you really need to remember is OAuth, which actually stands for Open Authorization, is for authorization. It deals with knowing what you're allowed to do or your permissions as a user in the context of a distributed system. And OpenID Connect is for authentication. It's knowing who you are, things like your profile data, your email address, things tied to your identity. OAuth, authorization, OpenID Connect, authentication. I'm not going to go into a lot of detail about either of the standards. Standards are vast and they leave a lot of implementation detail to the developer. But I'd like to make a recommendation for a really good piece of content to read. And you just have to Google what the heck is OAuth. It is a very popular post, and I think it explains it really, really well. And it also explains OpenID Connect, because these two are often used together. And in the minds of someone who is just starting to learn about authentication, they're often conflated, and so they should be. That's some really good material. There are so many presentations on YouTube. There are even illustrated guides. People have written comics about OAuth. The issue with OAuth, and why are people so excited about the standard? I wouldn't say we're all necessarily very excited, but it's quite confusing. It's very hard to get right because it comes in many flavors that we call flows. And I'm not going to go into detail about those flows because there are several of them and all the combinations of permutations thereof. But I like to recommend that you visit oauth.com/playground, which is the OAuth playground, and you can get a really good hands-on introduction. I think it's done really well if you would like to understand a little bit more about what the specific flows do and what the differences are. However, I'm going to give you my pro tip. For most cases, we're going to go with something called the authorization code flow with proof key for code exchange, PKC, which is actually pronounced Pixie, I'm told on good authority. And it is an absolute mouthful to try to remember. But luckily, it covers most of our bases. So this is the one that you really should remember. So, perhaps I should have titled my talk Building the Perfect Web Authentication Using OAuth 2 Authorization Code Flow with Pixie and Fastly's Compute at Edge. Wow. Okay, I'm going to back up a little now and try to apply everything we've spoken about in terms of standards to the flow, to the diagram that I said we're going to use to wrap our heads around this architecture. Okay, back to our end user in London. They try to visit a protected page, and Fastly in London, the Edge node is the gatekeeper for this. Say we determine that they are not authenticated. That's usually this is done by checking some cookies. And if they don't have cookies, we redirect them to an identity provider. A user logs in, does the whole process with the identity provider. The thing here is that, if you eventually want to change the security flow, or perhaps change the identity provider altogether, or add multi-factor authentication, or add a login with Twitter or login with Instagram, all of that is set up that you can do on the identity provider side, far away from the rest of your architecture. You can swap out the identity provider for another. Say you want to move from Google to something that's a little bit more enterprise like Okta, and you want someone to be able to log in with, say, their Salesforce identity, or perhaps you want to use AWS Cognito, whatever. You can just swap these bits out. The way this is architected, everything is kind of autonomous and nicely isolated away from your system. Back to the user logging in. Once they are successfully logged in, they are redirected to a preset callback path on your website. And here's what happens then. Now they have an authorization code in their request. This is sent from the identity provider. So the authorization code is a single-use code that is then exchanged by the Compute@Edge service for security tokens. And we check those security tokens. Security tokens, it really depends. There's typically two of them. There's an access token, which handles that's issued for authorization, and an identity token, which is the one for identification. And they can come in various shapes and sizes, and they usually encode who the user is and what they're allowed to do in the scope of your system as per your setup with the identity provider. So we exchange the authorization code for security tokens, we verify them and everything is okay. Then we pass the original request to the origin server and send back the content and everything is great. What happens on subsequent requests? We also store the security tokens that we get back from the identity provider, and we creates another big loop where Fastly at the edge verifies the security token, so the access and identity token, with the identity provider. Why they need to be verified? These are kind of cryptographically unique tokens, and that doesn't mean that they can't be compromised. So it is a good idea to keep verifying them. And why? While you can absolutely write crypto to run on the edge, think about it as a serverless compute node. While you can absolutely write crypto functions to do these verifications for you at the edge, something that you must consider is that you might want to revoke permissions of, I don't know, say you identify an attacker. You can only do that at the identity provider side of things. And if you are just doing cryptographic verification at the edge, you will never be able to know that a token has been revoked. Oh, nearly forgot about the Pixie. So all you need to know about Pixie is that it's another single-use code that is sent with the first request from Fastly to the identity provider. We send the auth code and a proof key for code exchange, and it's just an added mechanism of securing that request. So it's like double single use, if that makes sense. And just want to talk a little bit more about the magic in the middle, and I promise I will show you how it works. I kept saying edge a lot, edge compute, serverless computing. So this is compute at edge. It's Fastly's serverless edge compute platform, and we're going to build a service on top of it. And I get really excited whenever I whenever I can demonstrate this, because it's truly a fantastic a fantastic platform to build on. It's fast and it's always on. There's no cold starts or round trip delays. It's got a 35.4 microsecond startup time, which is about 100 times faster to anything else you might want to compare it to. I'm not even going to mention AWS Lambda. I'm V8, the JavaScript engine, has a 5 millisecond startup time, if I can remember. Yeah. It uses a new isolation technology, which is WebAssembly based. And it also has multi-language support, which means I get to write software in Rust, which is one of my favorite programming languages. I'm not going to insist about this, but I will offer resources at the end of this talk, and you can go and learn more about compute at edge. But anyway, let's do this. Let's try to build an authentication from start to finish in a talk. Okay, and now oops. Sorry. Right. Okay. I've picked an identity provider for this. It's Auth0. It took me about, I don't know, a minute or two to get to this point. I simply had to log in with GitHub. I did this just before the presentation. And I would like to integrate Auth0 into my application that doesn't exist, but for the purposes of this demo, we'll pick one later. Let's call it Dora's, then auth server. The application type can either be native or single page web application. Whenever you have a quick start with an identity provider, pick one of those two options, because they tend to be the configuration for the authorization code flow with Pixie, which is the recommended way to implement OAuth for single-page web apps or native apps, or whenever you don't have a way of storing client secrets. I've clicked create. That tends to be everything I need to do at this stage. I'm going into settings here. going to make a note of the client ID, and I'm going to come back for the domain later. Notice I'm not going to even worry about the client secret because we don't need it in this specific incarnation of OAuth. So here's the exciting bit. This is what a compute at edge service looks like. It's a Rust program. And this is all boxed up, and later this week there will be a blog post and you'll be able to download the code and implement edge authentication yourself. But I just want to demonstrate how quick it is to do. All we need here is a client ID and various other configuration options. Not going to worry about those. We just want a login flow of some kind at this stage. Okay, let's go back here. This is the dev server that Auth0 have created for us. I'm going to go into this bash script that I prepared earlier. Going to write that as the identity provider host. And we should pick an origin. Now, I wasn't feeling particularly inspired, but can always trust HTTP-Ben. HTTP-Ben doesn't need authentication, but I think it will serve us really well for the purposes of a demo because it has this nice endpoint called anything, which means it reflects a request back to us. So, without further ado, how do we set up a compute at edge service? Did I save everything? Yeah, okay. I'm going to use the fastly command line interface and just type fastly compute in it. The language will be Rust. You currently have a choice between Rust and assembly script, but we have more support planned, and we tend to update our blog regularly about what's coming. Singularly exotic fly.edge computer app. That's fine. That'll be the domain that's provisioned for me. I just press enter. I've just picked the defaults for now, and they should serve me right. Oops. This is what happens when you test demos before a talk. Just going to rename that really quickly. Lively touched fawn is a much better domain name anyway. Oh, come on. What have I done? The demo gods are not with me. I changed it in the wrong place. There we go. You won't have to do this. Slight mess before the demo. Apologies. Okay, we have physically positive polecat. It's getting configured. Fantastic. Oops. I just typed there. I certainly did. Back to my setup script. I'm going to run that now. And that will add the identity provider as a backend, as a Fastly backend to the service we just initialized, and the origin host as well. Is that going to work? Da, 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 da. Don't worry about the error. I always delete the backends before I add them, and obviously I hadn't added them before the demo. Okay, the WASM service has no package. WASM stands for WebAssembly, and that's because I should probably build it, right? Another incantation that's just going to compile the Rust package to WebAssembly. Nothing like a slow internet day. Okay. You know what? In the meantime, let's do these steps manually. So I was going to let my clever script take care of it, but you'll notice that so far I've only spoken about OAuth, and I've set up the Auth0 OAuth thing. Now, this is where a very clever bit about OpenID comes in, and it's that they maintain some public metadata on any OpenID Connect conformant server, which we're going to download. And we're going to download that here. And there's another file we're interested in, another JSON file. This is the base64 encoded data that we'll need to recompute the signatures that we use to sign whatever tokens we get back from Auth0. Right. Okay, cool. Of course, we couldn't do that. Let's just build. There you go. I've added those manually. You disappoint me, bash script. So you'll notice that what I've done so far, just for a quick recap, I have entered the client ID in a config file, and I've downloaded some public metadata that are JSON files that are available on any OAuth OpenIDC conformant authentication server, including Google, for example. So with that said, I'm ready to deploy. And with a little bit of luck, that should be everything I need to have the whole complex login form set up. Naturally, I wrote code ahead of time, and the code is an implementation of that whole flow that that I showed you before I said, okay, let's build a demo. And there will be a blog post that explains it much better than it is possible to do in a talk. And you can download a code and read through it in your own time. Excellent. So we have this service. We're not quite ready yet. I do not want to do that. Physically positive polecat. Great. We now have to go back to Auth0 and add this to a list of allowed callback URLs. And you'll notice that I've written callback here, and that's because my service has some pretty basic routing logic that just defines the callback path. Where is it? Where is it? Here we go. That defines the callback path as something that defaults to callback. So I was just going to use that for now. Great. Callback URLs. It's pretty much everything I need to do. Just in case I want to build the login later, I'm going to add this here, here, here. It's a bunch of copy paste. I will save changes, and with a little bit of luck, everything should work. So notice that right now I can make a request to HTTP bin, and it will show me, oops, it will just reflect that request back to me. Now, if I go via the edge compute service that uses HTTP bin as my origin server. And this is the cat app we spoke about at the beginning of this talk. So that's exactly what I wanted to see. And now I can kick off the whole login flow. So what has happened is that I'm already logged in with Google. Okay, I'm going to have to do this in incognito, aren't I? Or potentially log in with something else. Great. I just want to show you that it works. You should see that we go through fastly, and we should have an identity token and an access token from Google, which is what I used for a social sign-in, which comes boxed with Auth0. But you have like super fine-grained control depending on what service you use, be it AWS or Google or Auth0 or Okta or really any of the others, or even if you implement your own, you have really fine-grained control about the systems and groups and permissions and all of that. So just want to try this request URL in incognito. Oh, that's not going to work now, is it? Fine, I'll just log out of Google. Demo gods are not with me today. How unfortunate. There we go. I cleared the cookies. I get kicked back here. Sign up with something else. Another Google account, hopefully. No, it's the same one because I have a session. Personal email address. Seriously. Right, okay. I'm going to try incognito and hope this works because I can't be asked to deal with setting up Auth0 right now. Great, thank you. Ta-da! So our edge compute service treats H2Bibbin as an origin, and we handle the entire authentication flow. We also verify the tokens, and we forward these tokens to the origin as headers, and it's all done securely. And this origin can be anything. I'm using HTTP bin because I wanted an easy way to reflect the request. I should probably pick something more inspiring and to do with cats. Note for next time. Great. Okay, here's a quick recap. This is what we did. We registered with an identity provider. You have a choice of very many, but make sure in order for this to work out of the box that you use an OAuth 2.0 OpenID Connect conformant identity provider. Register your app. We made a note of the client ID and the address of the authorization server. Downloaded 2 JSON files. The demo code does actually come with a script that downloads this for you. And then on the Fastly side of things, we initialized a computed edge service, edited two lines of config in two different files. So the first one is in the service config file, and the second one is in the setup script, where we added the hosts of our origin server and authorization server. Then we compiled the WebAssembly binary for Computed Edge, deployed it, went back to Auth0 to the identity provider, updated the allowed callback URL, and then, if you do want to use the script, which I accidentally used in the wrong order, then that will actually create the appropriate backend, redeploy the service, and boom, you have a fully fledged, secure OAuth 2.0 OpenID Connect compliant authentication flow with Pixie using Fastly's Computed Edge. And you can do this in 5 minutes. And I hope that really excites you. So the next steps, I suppose, would be keep your eyes peeled. There will be a blog post on Edge authentication coming this week on our blog, and you can follow the Computed Edge team there. They have they're the best ones to talk about like all the exciting news and all the exciting developments coming up in the world of serverless edge computing. You can also ask to join our Computed Edge program. Currently, it's in limited availability. For anything else, for getting started with Rust or assembly script, please explore our developer hub and also keep in touch. You can tweet me at Dora Militaru or email me at doramilitaru@fastly.com. And I'd like to thank you very much for listening. And I hope you've really enjoyed our experimental foray today into authentication on the modern web in a way that is zen and not confusing, and hopefully feel a bit more confident now about building your own login flow. It is that easy. Thank you very much.